One very important part of an operating system is being able to handle interrupts. Interrupts can be anything from a timer to keyboard input to mouse input to exceptions. So let's make a handler for that. To start off with, we won't make a handler for every single type of interrupt, we'll just make one for the keyboard so that we can test it nice and easy. So the first thing we need to do is create a new file, IDT.cpp, pragma once, and we need to declare a struct. So struct IDT64. IDT stands for Interrupt Descriptor Table. Right, now to put in some values, we need to include our type defs.cpp, and inside we have uint 16 offset low, uint 16 selector, uint 8 ist, uint 8 types and attributes, uint 16 offset mid, uint 32 offset high, and uint 32 0. Now I won't go into the specifics about all of these values, but I will provide a link in the description if you'd like to learn about them. Then we create a function void initialize IDT, and we need to make an array IDT 64 IDT 256, because there's 256 different interrupts that we can handle. Right, so that's all fine and dandy, but let's actually choose a specific spot for our interrupt descriptor table to go in our memory. So for that we'll go to link.ld and create a new section. We'll call it IDT and we'll block 0x1000, so we'll make it a section that is 4096 bytes, and we'll align this by 4096 bytes as well. Inside of IDT we need to create a symbol. We'll call it IDT equals dot semicolon. So now we have a symbol that we can use in our program to find out where that is. Now we can just do extern IDT64 underscore IDT, and it'll point directly to this memory address. So we've essentially defined using the linker where our IDT will go in memory. That makes it very simple. So something I just realized is this block section here doesn't actually make this section a minimum of 1000 bytes. So we're going to need to change the location pointer of the linker. So dot equals dot plus 0x1000, and that will set the location pointer plus 4096 bytes, which will effectively define this section as a minimum of that size. Now in our kernel.cpp we will include IDT.cpp so that we can use this, and we will call Initialize IDT. Right, so we need to set up a handler for the keyboard. So we need an assembly function that will be our interrupt service routine for that interrupt. So we need to create a file IDT.asm, and we'll include this in our extended program.asm just under extern start. Right, so we need our assembly function interrupt service routine, and the interrupt for the keyboard, which we'll be using to test it, is the interrupt 1, so we have the interrupt service routine 1. And then we need to use interrupt return Q, interrupt return quad because it's 64-bit. We also need to declare this as a global ISR1 so that we can access it within our IDT.cpp. Now we can go extern uint 64 ISR1, which will give us the address of our command here. Right, so let's fill in our IDT entries. So we'll do for uint 8 t equals 0, t less than 256, t plus plus. Right, IDT t dot 0 equals 0, IDT t dot offset low equals uint 16, 3 brackets, uint 64, the address of ISR1, and 0x 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros and 4 Fs. The offset mid is the same, except these are FFFF0000. Just make sure there's 4 F's here. And this needs to be bit shifted by 16 to the right. Right, offset high needs to be a uint 32. Needs to be 1, 2, 3, 4, 5, 6, 7, 8 F's, and then 8 zeros, and bit shifted to the right by 32. IDT T.ist equals 0. IDT T.selector equals 0x08, and that's just a code segment selector that we declared in the GDT. IDT T.types and attributes equals 0x8e, which declares it as an interrupt gate, a 32-bit interrupt gate, which is what we want in this case. The next step we need to do is declare an IDT descriptor. So we'll do IDT descriptor in assembly, and we'll declare a word. This is the size of our IDT, so it's 256 entries, and each entry is 16 bytes. So that's 4,096 bytes, and the size has to be take 1, so 4,095. Then we declare word, the base offset of our IDT. Now we declared that in our link.ld file, which is just underscore IDT. So that's very simple. Now we need to make a function load IDT, LIDT, IDT descriptor, and then we enable IDT's interrupts with STI, and we return. This needs to be global load IDT. And before I forget, we need to extern underscore IDT so that we actually have access to this. And I believe that's all for now. Now we need to create an extern C void ISR1 handler, which we will include in our ASM, extern ISR1 handler, which we will call ISR1 handler. So when we get our interrupt, it'll call this interrupt service routine, and then it will call this function, which we can easily define in C. But we need to maintain the state of our registers when doing so. So we need to declare some macros. In 32-bit, we'd be able to use the push A command, but we don't have that in 64-bit, so we're going to make our own replacements. Just write down this, we'll be able to push all of the registers that we need to maintain, and then we'll be able to pop them all in a similar fashion. So then we can use that, push all, and then pop all. Now we need to reprogram the pick chip. And that's pretty simple, we just need to do out B 0x21 0xFD, out B 0xa1 0xFF. Now we can call our init IDT function, our load IDT function, which we declared in assembly, this one here. But to access that, we need to do extern C load IDT void. So now we can call this, which will call that, load the IDT and turn interrupts on, and then return. Then here, we need to signify to the pick chip that we have finished our interrupt. So we need to do out B 0x20 0x20 and out B 0xa0 0x20. Right. Now, since this is a keyboard interrupt handler, we need to read from the keyboard port. So we'll print string hex to string in B 0x60. If we don't read the keyboard value, it won't send any more interrupts. Now we should be able to test it and run it. And when we press a button, it will print the scan code to our screen. Now obviously we're going to need to translate this scan codes into something useful, but we'll be doing that in another video.